All right, we are doing this problem called remove stones to minimize the total. Let's have a read. You are given a zero index integer array piles where piles of I represents the number of stones in the ith pile and an integer k. You should apply the following operation exactly k times. Remove any pile and remove, okay, so basically choose any pile and remove half of the stones from it. Notice that you can apply the operation on the same pile more than once. Return the minimum possible total number of stones remaining after applying all the k operations. Okay. So our what we have to do is we have to choose any pile and reduce its size in half, and we can do that same. We can do that on the same pile again. And our job is to after what we are left with, we have to return make it minimum. So that would mean that I want to choose the maximum pile, right? Like if first I want to remove. So for example, let's say my pile is like 100, 50, I don't know, 25 and 40, something like that. Now, from which pile would I want to reduce the half if I want to reduce the number of stones? Obviously, the largest pile, right? So I'll reduce this largest pile into half, and then again I have to choose whichever is now the largest. Again, so this is the largest, so I'll reduce this into half. And if you have to choose now, again, then this is the largest, I'll reduce into half. So we be greedy at any point in time, whichever is the largest pile, we will reduce its size in half. As simple as that, right? So how do we accomplish it? So we want to always maintain a maximum, right? We want to reach the maximum, and how can we do that? So we can use a priority queue, a max priority queue, right? That could maintain the so that we can query or remove the maximum easily, right? That's fair. So let's add a priority queue of and let's save the indexes into this piles array in that priority queue. Okay, so priority queue equals to new priority queue, and we are going to save the indexes. So the way to do that would be if I am given a comma b, I want to return the max. I want to have the maximum here, so I'm going to do piles of b minus piles of a. This is going to give me the max priority queue, right? So if A is largest, then this will be become the most negative. Yeah. So this is how I save the priority queue. Now I just go for each int I equals to 0, I is less than piles dot length, I plus plus. I am going to add it into the priority queue. So priority queue dot add I. And now what I'm going to do is I'm given k operation. So for I equals to 0, I less than k, I plus plus. You take an element out of the priority queue. You also want to do something like and priority queue dot is not empty, right? There is only if you keep reducing into half and everything becomes a 0, uh, then also you don't do this. So in this case, what you want to do is uh, or you should apply the operation exactly k times. So you have to apply. So if there are 0 left, then 0 by 0 would be 0 by 2 would be 0. So okay, I can still apply the operation k times if you want me to. Uh, so I do this, and then what am I going to do? I'm going to do like a I remove the item from the priority queue, and now piles of max index equals to piles of I reduce this guy to half, And now I'm going to add this guy back into the priority queue, right? So priority queue dot add, I want to add it back, but now when I add it back, the value should reduce, right? So this is that, and then you want to do return. Okay, now we want to just add them up. So now we have to return what? The minimum stones left. Yeah, so now we just do stones equals to 0, and you return the final remaining stones. Okay, let's have a run. And the answer we got is wrong. Let's have a look. So 549 expected is 12 and we got 10. So 549, let's see what would happen with 5, 4 and 9. So you have 5, 4 and 9. The largest is 9. I'll divide it into how many times I can do this? K equals to 2. So first I divide 9. I divide 9 by 2. So I'll get 4, right? And then I divide this 5 into 2. Uh, I'm going to remove that many. Okay. I'm going to remove that many. So piles of this minus equals to this. Okay. Run again. Right. Both works. Submit. And it gets accepted. All right.